So welcome back to the deep dive. Today we're really getting into something that sounds like science fiction, but is actually happening right now on factory floors.
Yeah, and it's something that kind of shatters this illusion we all have about modern technology.
Right, exactly. So to set the stage for you, I want you to imagine stepping into this newly commissioned state-of-the-art biomanufacturing facility. It's 4 in the morning.
Okay, setting the scene. I like it.
Yeah, so you walk past the C-suite offices, right? And you look at the screens, the executive dashboards, and they are just glowing this serene, uninterrupted green. It says, flawless operational efficiency across this massive $10 million bioreactor array.
Everything looks perfect on paper, or, well, on the screen.
Exactly, on the screen.
Right.
But then you actually step out onto the sterile floor, and instead of perfection, you find this totally sleep-deprived technician wearing a full hazmat suit, and they are manually scrubbing down the inside of an automated plate handler.
Oh.
Right, just scrubbing it down, desperately trying to salvage this ruined batch of synthetic antibodies. I mean, the dashboard says the robotic facility is this masterpiece of precision engineering, but the technician at 4 a.m., they know the raw truth, which is that the entire automated landscape is completely blind.
And that dissonance between the highly sanitized corporate dashboard and the physical, gritty reality of the lab floor, that is exactly the core of what we're looking at today.
Yeah, it's wild.
Because the executive suite, they genuinely believe they've purchased this flawless, fully autonomous ecosystem.
Right, they think they bought a magic box.
Exactly. But the reality is they have invested in a highly sophisticated, incredibly high-speed system that possesses absolutely zero sensory feedback regarding its own physical actions.
So to unpack this, we are tearing into a really fascinating stack of sources today.
Huh?
We've got an industry report detailing what experts are calling a $1 trillion blind spot in enterprise growth.
Which is a massive number, even for big tech.
Huge. And we're analyzing that alongside this very specific high-conviction playbook. It originates from this moonshot creative syndicate, and it's led by a mind operating very much like a hyper-literate, meme-savvy creative director. Kind of a Tanmay Bat type, if you will.
Right, someone who really understands how to slice through the corporate noise.
Exactly. And they are using Dieter Ram's minimalist design philosophy to completely re-engineer how B2B executives perceive their own physical infrastructure.
And the really fascinating focus of that manifesto is a figure they refer to as the quiet architect.
The quiet architect. I love that name.
It's great, right? This is an engineer operating out of Nagpur who is basically bypassing all that massive, bloated cloud infrastructure everyone else is obsessed with.
Yeah, totally ignoring the cloud.
Right, and instead he's deploying hyperlocal edge AI to fix these invisible physical leaks in automated labs. And the way this moonshot syndicate is packaging that raw, unvarnished truth, it's becoming an incredibly lethal viral tool to cut through corporate PR.
Let's start with the mechanical reality on that lab floor, because I think we all buy into this myth of the infallible machine.
Oh, absolutely. We're conditioned to.
Right. Like, we see a pipetting robot moving across a gantry at, 2 meters per second, executing 1,000 liquid transfers an hour, and we just assume it possesses absolute spatial and operational awareness.
We project human consciousness onto the hardware, basically.
Yeah, exactly.
I mean, think about it. When a human technician pipettes a fluid, they feel the resistance of the plunger, right?
Right, you get that tactile feedback.
Exactly. They see the meniscus of the liquid rise in the plastic tip. They visually confirm the transfer is happening.
Because they have eyes.
Right. But in a modern automated lab, the pipetting robots, the colony pickers, the plate handlers, they are executing all these complex routines based entirely on open-loop software commands.
Open loop meaning it doesn't check its work.
Exactly. The central software just sends an electrical impulse. It says, move to coordinate X, lower Z-axis by 12 millimeters, apply suction to draw 1 microliter of reagent.
And the motors just do it.
The motors execute the mathematical instruction, and the millisecond that electrical current finishes flowing to the motor, the software just logs a successful operation.
But software intent is not physical reality.
Not at all.
I mean, the software knows it asked the motor to spin, but it doesn't know if the plastic tip was actually properly seated on the nozzle.
Exactly.
It doesn't know if the source wheel was unexpectedly empty, or if the region had congealed into a solid. It just blindly assumes a perfect physical universe.
And the sources introduce a really great term for this, which is the fast idiot.
Fast idiot, yeah.
A pipetting robot is just a fast idiot. It executes instructions at lightning speed with absolutely zero self-verification.
It's just moving blindly.
Right. It logs commands, but it inherently lacks any rich quality control signals at the actual point of physical contact.
Okay, let's unpack this for a second, because this really sounds like a blindfolded chef to me.
Oh, that's a good way to put it.
Right, like the chef knows they swung the knife exactly as they were programmed to, at the exact right speed and the perfect angle, but they have literally no idea if they actually chopped the carrot or if they just hit empty air.
Exactly.
So are you telling me that $10 million bioreactor arrays are really just operating blindfolded?
That is a highly accurate representation of what the sources call the bioreactor blindspot, yeah.
Wow.
Because when a physical mispipette occurs, say, an air bubble is drawn up instead of a critical catalyst, it registers nowhere in the system logs. Nowhere.
It's just totally invisible.
It is a completely invisible mechanical error. The machine just moves on to the next command.
And if it's invisible to the software, the machine just keeps blindly building on top of that error.
Yeah,
Right.
it compounds horribly.
So walk me through how this actually plays out in a bioreactor pipeline. Because we aren't just talking about, a puddle of spilled water on a desk. We were dealing with highly sensitive biological assays.
Yeah, the stakes are incredibly high here. So let's look at a standard 14-day mammalian cell culture process.
Okay, 14 days.
Right. Say they're cultivating Chinese hamster ovary cells for monoclonal antibodies.
Pretty standard stuff in biotech.
Exactly. Now, on day 2, this robotic plate handler is tasked with transferring a highly specific nutrient matrix into the primary reactor.
Okay, day 2.
The robot arm moves, the vacuum pump fires, but a tiny misalignment in the plastic microplate means the tip hits the rim. It draws air instead of liquid.
Oh, no.
And what does the software do? The software logs a successful transfer.
Because the motor spun.
Because the motor spun. So for the next 12 days, the system continues to strictly regulate the temperature. It pumps in expensive oxygen mixes. It monitors pH levels, totally assuming the nutrient matrix is present.
But the cells are starving. I mean, the batch is already dead on day 2.
It is entirely compromised, but you won't actually know that until day 14.
Oh my God, that's almost 2 weeks of wasted resources.
2 weeks. You extract the harvest, you run it through a mass spectrometer, and you finally realize your protein yield is practically zero.
Wow.
By that time, you have burned hundreds of thousands of dollars in reagents, in energy, and facility time.
And when the C-suite looks at the logs,
When the executives look at the logs to find out what went wrong, the dashboard shows 100% operational compliance.
which brings up a really glaring question. If you are an executive sitting in the C-suite and you're reviewing your quarterly statements, why doesn't your financial tracking catch this?
Right, that's the multi-million-dollar question.
Yeah. I mean, how does a missing drop of liquid just vanish in the data but still completely sabotage the bottom line?
It really comes down to how these losses are categorized in traditional enterprise tracking.
Okay, how so?
So when you have a massive failure like the one we just described, it absolutely hits the profit and loss statement, the P&L.
Right, the money is gone.
The money is definitely gone. But because the system logs claim everything operated perfectly, mechanically speaking, the C-suite cannot attribute the loss to a mechanical failure.
Because the fast idiot said, I did my job perfectly.
Exactly. So they look at this sanitized operational data and they conclude, well, it must be a biological anomaly, or maybe it's a bad batch of raw materials from a vendor.
Right, they blame the chemicals, not the robot.
Or they just write it off as an unavoidable yield loss that's just inherent to complex science.
They write it off as a market condition, basically, rather than recognizing it as a completely preventable mechanical flaw.
Precisely.
Yeah.
Biotech executives are out there struggling with these hidden yield losses because their diagnostic tools are just pointing in the wrong direction entirely.
That is so frustrating to think about.
It is. I mean, they're trying to optimize their biological formulas, or they're in boardroom meetings trying to renegotiate supply chains, completely unaware that their $10 million fast idiot just missed a microliter of fluid at 4 a.m. on day 2.
That is wild.
Catching out-of-spec behavior at the mechanical level, it is not a minor IT tweak. It is a critical financial intervention.
Okay, let me stop you there.
Yeah.
Because if a modern data-driven enterprise actually realizes they have a blind spot like this, their immediate corporate reflex is to just throw it to the cloud. Right?
Oh, 100%, that's the playbook.
They say, let's put sensors on everything. Let's stream all that raw data to a massive server farm in Virginia, run a complex machine learning model on it, and just build a giant central data lake.
Yes, the data lake.
Right, the magical data lake that solves everything. But this industry analysis we're looking at specifically warns against this. So why does centralizing the data actually make this trillion-dollar blind spot worse?
It essentially comes down to physics and latency.
Physics.
Yeah, the sources emphasize what they call the edge vision mandate. When you're dealing with a pipetting robot moving at sub-second intervals, the integration gap, like the actual physical and temporal distance between the physical pipette tip and a centralized server rack, is fatal.
Let's put some hard numbers to that latency if we can. Like, what are we actually dealing with when we send this video feed to the cloud?
Okay, so say you mount a high-definition camera on a bioreactor, right?
Okay.
And you stream that video feed to a cloud server. You are dealing with network transmission time, then you have cloud processing queue time, the actual algorithmic inference on the server, and then the return transmission of a halt command back to the machine.
That sounds like a lot of steps for a fast robot.
It is. Best case scenario, on a really good dedicated fiber line, you might see 150 to 300 milliseconds of round-trip latency.
And in 300 milliseconds, that robotic arm has already moved to the next, well, ejected the wrong fluid and completely cross-contaminated the entire plate.
Exactly. It's too late.
It's like driving a Formula One car at 200 miles an hour, but your steering wheel is actually being controlled by someone sitting in a server farm 500 miles away who's just watching a webcam feed.
That's exactly what it's like.
By the time they tell you to turn left to avoid a wall, you have already hit the wall.
Right. And that temporal distance is exactly why the cloud fails in industrial automation. The failure has already compounded before the cloud even registers that an event happened.
Wow.
Moving the analytics to the edge, meaning the physical processing happens on a local module directly attached to the machine itself, that cuts that latency by 40 to 80%.
But there is actually a secondary trap to centralizing this data, beyond just the speed issue. And the sources draw this parallel to the medical field, specifically ICU nurses, which I found incredibly revealing about how we design these monitoring systems.
Oh, the alert fatigue phenomenon? Yes.
Yes, talk about that, because that is so relatable.
So over the last decade, hospitals pushed really heavily to centralize patient monitoring.
Right, the central nurses station.
Yes, exactly. Every heartbeat, every oxygen fluctuation, every minor change in blood pressure from dozens of different beds is sent to a single central nursing station.
Yeah.
The intention was total visibility.
But the reality...
The reality was sensory deprivation through noise.
Because the central hub just becomes this wall of constant, unrelenting beeping.
And human psychology dictates that when an alarm is constant, it basically ceases to be an alarm.
Right, it just becomes background noise.
Exactly. It becomes background noise. ICU nurses routinely end up ignoring these centralized monitors just due to sheer cognitive overload. It's too much.
You just can't process it all.
Right. And the exact same fatigue happens in a biomanufacturing facility. If you rely on the cloud to monitor every single micro movement of 100 different robots, and you push every minor deviation to a central executive dashboard, the alerts lose all their meaning.
The technicians just tune them out.
They tune them out, and the batch is ruined anyway.
So relying on the cloud for real-time mechanical intervention is fundamentally broken. Processing absolutely must happen at the exact point of mechanical contact.
Precisely.
Which introduces us to the ground-level solution in this playbook and a figure they call the quiet architect.
PRASAD from Nagpur.
PRASAD.
Yeah.
I have to highlight a detail from the manifesto here because I love this. The author notes that PRASAD's mother tells her friends in India that her son, quote, fixes factory printers.
Yes, I love that part.
Right. And the author points out that, functionally speaking, she is absolutely correct.
It completely strips away the Silicon Valley mystique, doesn't it?
It totally grounds this entire conversation. Because we hear artificial intelligence and we immediately picture, a glowing, omniscient brain floating in the metaverse. But PRASAD is out there doing gritty, high-stakes mechanical troubleshooting.
Yes, very grounded work.
So what is he actually deploying on the lab floor? Let's get into the nano-banana of it all.
Right. So his team is executing what the sources call restorative engineering.
Restorative engineering.
Yes. Remember, the software stripped the machine of its connection to physical reality. Restorative engineering returns operational agency to the floor by essentially bolting low-cost vision systems directly onto the moving robotic armature.
Okay, I want to push back on this just a little bit because it sounds almost too rudimentary.
Fair enough.
We have a $10 million bioreactor array, right?
Mm-hmm.
It's suffering from multi-million-dollar hidden yield losses. And the revolutionary solution is attaching a camera to the robot arm. How does that bridge the gap?
Well, it isn't just a basic camera. It is hyperlocal, Python-based edgeai.
Okay, edgeai.
The camera is simply the optical sensor. The really crucial element is the edge computing module physically mounted right next to it. They are using global shutter machine vision cameras, which can capture high-speed motion without any distortion.
So they don't get blurry when the robot moves fast.
Exactly. And those cameras feed raw frames directly into a heavily quantized neural network that is running locally on the gantry itself.
Let's break down how that actually catches the error in real time. The central software sends the electrical command. Draw 1 microliter of liquid. What happens next?
The robotic arm moves, and the local edge camera, which is staring right at the transparent pipette tip, captures the actual physical event. The local Python script running on the edge module analyzes the pixel data frame by frame in real time. It is specifically looking for the optical distortion that is caused by the meniscus of the fluid rising inside the plastic tip.
So it isn't waiting for a cloud server to tell it what it's seeing. It is evaluating the physics right there on the metal arm.
Millisecond by millisecond.
Wow.
If the software says the suction command is complete, but the edge module does not detect that visual signature of the fluid actually entering the tip, the local edge device violently overrides the central software.
It just cuts it off.
It triggers a hard physical halt on the machine's safety circuitry before the arm can even move to the next well.
So it stops the fast idiot in its tracks.
Immediately.
Now, the sources mentioned adapting heavy industrial techniques for this, specifically something called the NanoBanana 2 application, which I have to say sounds like a joke name, but it's a serious protocol, right?
It is a serious protocol, and it really highlights the cross-pollination of industrial engineering here.
Okay, explain NanoBanana 2.
So NanoBanana 2 refers to a methodology adapted from heavy manufacturing. Think about like inspecting automotive welds on a car assembly line or monitoring heavy fluid pipelines.
Big, dirty physical jobs.
Right. In those environments, you cannot rely solely on a single camera. There might be occlusion, or the lighting changes suddenly, or there's smoke.
So vision alone isn't enough.
Exactly. You have to merge optical data with localized force and position sensors.
So PRASAD's team is taking the rugged, totally fail-proof inspection logic of a car factory and shrinking it down to monitor delicate biological arrays.
They are creating a multi-sensory web at the exact point of action.
A web of sensors.
Right. So if the camera is blinded by, say, a harsh reflection on the plastic microplate, the microforce sensor on the z-axis can confirm whether the tip physically engaged the bottom of the web.
Because it feels the bump.
Yes. The edge module processes these merged sensory inputs locally, making a definitive, instant judgment on physical reality. No cloud required.
Now, the sources refer to the way this solution is communicated as Feynman compression.
Oh, this is a great concept.
Let's define that for the listener, because it seems central to how this quiet architect actually operates and gets buy-in from people.
So Feynman compression, which is named after the physicist Richard Feynman, is basically the ability to take a deeply complex, highly technical mechanism and compress it down into a completely stripped-down, perfectly accurate explanation that absolutely anyone can understand.
Right. And you do it without relying on jargon.
Exactly. No buzzwords.
So they're taking, like, quantized neural networks running on-edge tensor processing units, evaluating fluid meniscus optical distortion, and compressing all of that into what?
They compress it into the robot has no eyes, we gave it eyes, now it catches its own mistakes.
The robot has no eyes. Man, that hits hard.
It really does. It completely demystifies the AI.
Yeah.
It positions the technology not as some magical conscious intelligence, but just as a specialized physical tool.
A tool with a very specific job.
Right. And this brings us to a massive challenge, which is, how do you physically design that tool?
Right, the hardware itself.
Because if we are installing this hardware into a sterile biomanufacturing lab to solve alert fatigue, we absolutely cannot just slap a bunch of chaotic, blinking, noisy boxes onto the gantry.
Which is where this moonshot creative syndicate comes back in, merging advanced engineering with strict design philosophy. They explicitly apply the principles of Dieter Rams to this biotech infrastructure.
Dieter Rams is, well, he's arguably the most influential industrial designer of the 20th century.
For sure.
His work at Braun in the 1960s basically established the entire aesthetic foundation for modern consumer electronics.
Heavily influenced Apple, right?
Deeply influenced Apple. And his core ethos is less but better. Design should be unobtrusive, it should be honest, and it should be stripped of absolutely anything non-essential.
The prompt and the sources provide these incredibly vivid guidelines for how this actually looks in the lab, and we really have to visualize this for you.
Let's paint the picture.
So a modern automated lab is basically a sea of monochromatic silver, white, and brushed aluminum. You've got this strict clinical lighting, casting, calculated shadows everywhere. It's very clean.
Very sterile. And right at the mechanical junction of the pipetting arm, you have this edge computing module.
And it is not glowing with RGB lights.
No, absolutely not. It is a purposeful matte black module.
The visual composition relies on 60% negative space, which is wild because it completely rejects what we expect from Silicon Valley AI startups today.
Oh, completely.
When a standard tech company pitches AI, the user interface is just overwhelming. It's like floating holograms, fake blue UI elements, 1,000 data points spinning around on a dark mode screen, lasers scanning everything.
Because standard tech companies are selling the illusion of complexity to justify their massive valuations.
Ah, that makes so much sense.
Right. But RAM's philosophy dictates that products are tools. They are not decorative objects. They are not works of art. Their design should be neutral and restrained, basically leaving room for the user's operational focus.
The manifesto actually calls this dwell time engineering, applied to the physical workspace.
Yes. Dwell time engineering.
Let's unpack that term, because usually, when we hear dwell time, it means keeping someone addicted to scrolling a website or an app. How does that apply to a physical hardware module in a lab?
In this specific context, dwell time engineering is about actively managing the cognitive load and the attention span of the frontline technician.
Okay.
Think back to our ICU nurse who is suffering from alarm fatigue.
Right, the wall of beeps.
Exactly. If the edgeai module on the robot looks like a chaotic sci-fi movie, flashing blue lights, complex data readouts, scrolling rapidly across a tiny little screen, it creates massive cognitive friction for the person standing in front of it.
Because if the technician has to spend 10 seconds just interpreting the glowing lights to figure out what went wrong, that is 10 seconds of friction that makes them hate the machine.
Yeah, and it causes them to eventually just ignore it. The DRAM's approach strips all of that away. The hardware is literally just the matte black box, the sharp 100mm macro lens, and perhaps a single dull amber status indicator light.
And on the actual monitor, like the UI that the tech looks at, it's just a minimalist, thin red bounding box tracking the fluid level. Nothing else.
That's it.
Wait, so by stripping away the UI, they aren't just making it look elegant. They are actively engineering the operator's decision-making speed.
Yes.
That completely flips how enterprise software is usually designed. They aren't trying to impress the user with data. They're trying to minimize the time the user has to even look at the screen.
Exactly. They want the human technician to just glance at the dull amber light, know instantly that a mispipette occurred on plate 4, manually correct it, and restart the batch.
It's respectful of the worker's time.
It validates the undocumented labor of the human operator by giving them a reliable, instantly readable tool. It really fosters this seamless hybrid workflow.
Which brings us to arguably the most fascinating layer of this deep dive.
Yeah.
The false promise of self-driving labs.
This is where the marketing meets the reality.
Right. Because for the last 5 years, corporate PR has just been obsessed with the idea of total autonomy.
Oh, that's all they talk about.
The pitch is always that you could just turn off the lights, lock the doors, let the robots run, and the AI will handle the science perfectly.
But the industry analysis source makes it glaringly clear that full autonomy in bioprocess labs is completely unrealistic in the near term.
It's a pipe dream.
It really is. The operational depth is capped by incredibly fragile data infrastructure.
You cannot have a self-driving lab if the vehicles are blind.
Exactly. The true future of biomanufacturing is not complete machine autonomy. It is the hybrid lab.
A hybrid lab.
Yes. It is a synthesis of machine speed, edge-level sensory verification, and human operational judgment.
And this raw reality that the multi-million-dollar self-driving lab is actually blind, fast idiot, this is what is being weaponized by the moonshot creative syndicate to capture the attention of these executives.
Yes, we were talking about a highly calculated viral meta strategy.
This is where that Tanmay Back-esque creator persona comes into play, right?
Exactly, because think about it. How do you market hyperlocal Python edge computing to a non-technical chief financial officer?
You don't. Their eyes will glaze over.
Right. You do not sell them on the quantized neural network. You sell them on the P&L leak.
You hit them where it hurts, the bottom line.
You expose the systemic failure that their official PR team has been ignoring. And the mechanics they use to construct this message on platforms like LinkedIn or X, they are mathematically designed to trap executive attention.
Yeah, the manifesto outlines a really strict syntax for this campaign.
It begins with what they call a lexicon and transactional audit.
Right, they outright ban 21 specific corporate buzzwords. I mean, they completely refuse to use words like synergy or seamless or paradigm.
Because those words trigger instant executive fatigue.
They just sound like white noise.
They signal sanitized PR. As soon as a CFO sees the word synergy, they stop reading.
They also explicitly block the rule of three, which is crazy because every marketing class on Earth tells you to group concepts in threes to make them memorable.
Right, beginning, middle, end.
Yeah, but this playbook bans it. They use lists of 2 for stark contrast, or they use lists of 4 to break the expected rhythm.
It keeps the reader off balance.
And they enforce hard stops. No trailing sentences, no passive voice, no negative parallelisms. They do not write, "We do not rely on the cloud, we rely on the edge."
They state the affirmative directly. We compute at the edge.
Right, and they use aggressive vertical spacing to physically pull the reader's eye down the screen on their phone. They apply Dieter Rams's concept of negative space to the actual text of the post itself.
It is brutal, unvarnished minimalism applied directly to copywriting.
That is so smart.
When a biotech executive is scrolling through a feed that is just filled with fluffy AI promises, and they hit this block of text that is stark, spaced out, and violently honest, it acts as a massive pattern interrupt.
And the core message they are blasting across these platforms is, honestly, the perfect Feynman compression of everything we've talked about today.
What's the line?
Your automated lab is blind. Watch the hands.
It's brilliant. It shifts the executive's perspective immediately.
Watch the hands. I love it.
I mean, they're sitting in the boardroom trying to understand why their quarterly yield dropped by 14%. This messaging tells them exactly why.
It says, it is not your market strategy. It is not your supply chain. It is your $10 million robot missing a single microliter of fluid, and your cloud infrastructure is way too slow to catch it.
It transfers the blame from a vague market condition to a specific, highly solvable physical infrastructure flaw.
Right.
And then, crucially, it hands them the solution. PRASAD from Nagpur, a matte black camera, and restorative engineering.
It establishes immense authority because it just completely abandons the flashy sci-fi aesthetic.
Totally. By embracing the gritty, physical reality of the lab floor, they build massive trust. They aren't selling magic. They are literally just selling a pair of eyes for a blind machine.
Let's review the sheer scale of what we've uncovered here today, because it's a lot.
It really is a paradigm shift in how we think about automation.
Right. We started with the realization that the most advanced automated facilities on Earth are basically populated by fast idiots.
Machines executing software commands perfectly while remaining totally oblivious to physical failure.
And we detailed how a single microscopic failure, a misaligned plate, an empty pipette tip compounds over days or even weeks. It vanishes from the cloud logs, only to basically detonate on the executive P&L statement as a massive, unexplainable yield loss.
And then we explored the latency trap of the cloud, proving that sending physical data to a centralized server is like remote controlling a race car with a 500-mile delay.
Right. The failure happens faster than the network can even report it.
Which led us to the quiet architect's brilliant solution, restorative engineering.
Deploying localized edge AI, adapting heavy industrial inspection techniques like the Nano-Banana 2 protocol to process physical reality in milliseconds.
Overriding the software exactly when it matters most.
And we saw how packaging that solution in the rigorous, unobtrusive minimalism of Dieter Rams, the matte black, the negative space, the total rejection of sci-fi UI, how that manages the cognitive load of the frontline worker.
They essentially designed a physical tool that cures alert fatigue.
Cures it entirely. Finally, we deconstructed the viral playbook that leverages this raw truth. By banning corporate jargon and employing Feynman compression, they force these B2B executives to confront the physical blindness of their own infrastructure.
It's a masterclass in messaging.
So if you are listening to this right now, and you are staring at an executive dashboard that tells you your enterprise is operating flawlessly, you really have to ask yourself a hard question.
A very uncomfortable question.
Where are your blind spots? Where is the software logging operation successful while the physical reality is quietly hemorrhaging on the floor?
Are you relying on a centralized cloud to monitor a problem that demands a hyperlocal set of eyes?
The broader implications of this are honestly staggering.
They are. Because we are racing toward an automated future, assuming that centralized artificial intelligence will just seamlessly orchestrate physical reality for us.
But if the absolute cutting edge of biomanufacturing is currently being held together by bolting a local camera onto a robot arm and trusting the judgment of a tired human technician.
Exactly. What other fully automated systems in our modern world are secretly relying on undocumented human labor to catch their invisible mistakes?
Right. Our logistics networks, our automated supply chains, our physical manufacturing grids operating like blindfolded chefs, chopping at empty air while the scorecard reads perfect.
When we finally turn the lights on across all our automated infrastructure, we may find that AI's most critical role is not replacing human consciousness at all.
No.
Its greatest purpose might simply be acting as our eyes at the edge of the physical world.
Restoring agency to the floor. Watch the hardware. Watch the hands.